Hi, Chem 1212. Here's a short video just to kind of reiterate some of the topics we've talked about so far. What you have here is a mechanism. Above this line is a mechanism, and I've given you both the data about what the reaction is here to the left of this other line, and to the right of it you'll see some data for the thermodynamics of what's going on here. So if we look at this, it says that the first step, if you take a look, it says the first step here, step 1, the first step of the mechanism, it has an enthalpy change of positive 10 kilojoules. And what you can see is that as we follow this along, there's an increase in the energy from the reactants going up to I1. All right, and we can do the same thing then with all the other reactions as well. If we wanted to, we can look at the next step here. As it goes up, it becomes exothermic because it gives off energy, so the energy goes down here, as you can see, and that matches what we see in the given data. So there's 4 steps, 1, 2, 3, and 4 to this mechanism. And as well, we can see that there's 1, 2, 3, 4 of these activation energies. Just to remind you that every one of these hills has an activation energy which goes from the starting point, the reactants, up to the top of the hill called the activation energy. So these 4 steps right here are represented as 4 distinct little reaction collision pathways. All right. So what's the overall reaction for something like this? Well, as we look at it, the I1s will cancel, the I2s will cancel, and that's because they're on opposite sides of the arrow. The I3s will cancel, so this is really a reaction of R going to P. And for Hess's law, you ought to be able to immediately say, I know exactly what the energy is. For Hess's law says, if I add these up, if I add them, then I'll get the reaction for R sub P, I'll get its enthalpy change. So delta R, the change in enthalpy for the reaction for the whole thing here is going to be minus 10, plus 10. Those guys cancel out, so it's minus 70 kilojoules. All right, so just a connection here between some of the things we're going to see in the future again, which are these reaction profile diagrams, and a mechanism. And here's the overall, it's the bulk reaction, or sometimes called the overall reaction. So just a little quick ditty here for you. Hope this helps clear up some of the ideas we've been talking about.